Okay, it's 7 o'clock Eastern time. Good evening, everybody. My name is Dennis Devos. It's a great pleasure to be here joining you from the Great White North, a couple of hours out of Detroit, up in Canada, and it's a great pleasure to be presenting to the Tennessee Northeast section, Duke's home section. And Duke, I appreciate you inviting me to present here tonight. Yeah, Duke and I have known each other many years, and I was privileged to be asked by Duke to be one of the first instructors to teach his root cause analysis class at ASQ, and thanks again for that. It's wonderful material. So tonight I'm going to be talking about some really basic concepts, nothing as cutting edge or as interesting as what Ann just showed us, but I want to bring us back to basics. We know that when ISO 9001 third edition came out in the year 2000, it introduced this concept of the process approach. And the process approach really just means means what it says on my slide. We ought to build our QMS around the basic business processes in our organization. And when I say process tonight, I want you to just instantly think about flowcharts, because that's what I do. Flowcharts. And all of us went to high school. All of us know what flowcharts are. So in the year 2000, the standards writer said, stop the insanity. Stop these big, bulky quality manuals that are just written around, the numerical clauses of the standards. Instead, right, make the quality management system standards work for you. Instead of building your QMS around I'll go ahead and say it, artificially numbered requirements inside the standard, for heaven's sakes, build the thing based on your own business and your own processes. It's a simple idea, but not enough of us have done it yet. And for heaven's sake, here I am 23 years later, still talking about this. What I'm going to talk to you about tonight is building the architecture of a quality management system around your key business processes and using a process approach, which is just going to be a series of flowcharts. So I'm going to take you through this. I'm going to show it to you. And I've done this presentation a lot of times over the years, and people seem afterward almost to be relieved that I'm giving you permission to do these things this way. As I go through it, of course, you know how intuitive this is, and I've heard people sort of say, I didn't know we could do it that way. That makes so much sense. So yes, you can. I'm giving you permission, if you like what I'm talking about tonight, to go ahead and do it in your organizations. So let's talk about the process approach as the basis for your quality management system. I'm going to start out with some fundamental definitions. I'm going to talk about the aspects of processes, inputs and outputs, enablers or controls, using resources, performance metrics, etc. I'll talk a little bit about the approach, then the benefits of the approach. I'll talk about the differences between business processes and departments, because they're not usually the same thing, and assigning responsibilities, etc. I have about 35 slides. This presentation takes about 35 to 40 minutes, so there is lots of time for Q&A at the end. I do have a point about halfway through this presentation where I stop and I ask for questions. I'm going to give you some introductory remarks and some introductory concepts. And it's important that all of us sort of understand and even agree with the first part of this presentation before I can move on. So when I get to that point, I invite questions or comments. Don't worry about the time. I'll manage the time. So I come from the automotive industry, and of course, in the automotive industry, we are actually required to audit by process. So when I teach auditing, whether it's to an automotive audience or to just a basic ISO 9000 audience, I always teach my auditors to audit by process. And that's really the basis for the presentation I'm sharing with you tonight. So if I require you to audit by process, of course, you need to know what a process is. So we'll start with a fundamental definition. We know that a process is a set of interrelated or interacting activities. It's a flow chart that use inputs to deliver some output, right? And there's the clause, and there it is, right? A process, it's a series of steps, take some input, make some output using resources. Intended results, right? We can call it an output, it's our product, it's our service, whatever it is. And then, of course, as you talk about an intended result, well, the intended result is very often what we've agreed to sell to our customer, right? So we make a promise to our customer to deliver them some type of product or service. That's the intended result. Sometimes our actual result isn't exactly what we intended. And I often think about that little gap between the intended result and the actual result as quality. I know that's an unconventional definition, but seems to work. Everyone in the world who makes something basically follows this very high level process flow chart, right? So there's some customer, you quote on some new work, you get awarded the work, a contract comes your way, you design your product or service. Then if you're designing a product, for example, out comes a bill of material that becomes an input to purchasing. You buy stuff that then you integrate into your manufactured product, and then it goes to the shipping. You recognize that each of these steps, right, it is in sequence, it relates to the next one. The output of each block becomes the input to the next block. So we have we get a contract from a customer to sell them something. That's an input to our design. We have to design according to what we promised. Again, one of the outputs of a product design is a bill of material, becomes an input to the purchasing function. They buy the stuff, the truck's back in, out come all the pieces that become an input now to my assembly lines. Out comes manufactured product that goes to my shipping docks. Basic stuff. So when we design our quality management system around the key processes of our business, we need to identify and think in terms of business processes rather than departments. One of the ways that I suggest you test whether or not something is a process is to ask yourself, right? If this is truly a process, it has an input and it has an output. Remember, that's literally our definition. So I'm doing the laundry. We know that doing the laundry is a process. You can think of it like a flow chart. It's a series of steps. There's an input, dirty clothes, and through a series of steps, using resources like soap and water, out comes clean clothes. We want to barbecue a steak. Is that a process? Yes, it is. The input is raw meat and the output is cooked steak. We're going to wash the car. We know that's a process. The input is a dirty car. The output is a clean car, et cetera, right? The last three are just more complicated versions of that. So what I suggest to you is that we can use the definition of a process to help us decide what is and what isn't a process. We literally just did that. So now the things on this screen are processes. Doing the laundry, barbecuing a steak, etc. We tested that. We tested that these truly are processes because they have inputs and they have outputs. A lot of times we think we're talking about processes, but we're really talking about departments. Everyone in the world who has ISO 9001 meets clause 4.4, and they create this flow chart, right, of processes and their interaction, etc. But a lot of them that I see have departments and other things, boxes of things inside of this larger flow chart that are not processes. They're either departments or they're things like health and safety, which isn't a department. It's actually nothing. Or environmental, or heaven forbid, management. What are those? They're nothing. They're not departments. They're not really processes. that we feel like we have to somehow squeeze those in. Well, it's hard to squeeze those in as processes because in fact they're not. Human resources is a department. Quality assurance is a department. Now, yes, there are processes within these departments. Human resources might have processes inside of it like hiring and orientation, maybe training, maybe negotiating benefits with an insurance company. Each of those are processes within a department. Quality assurance, same thing. QA is itself not a process. There's no input, there's no output, but there are processes inside of the QA function. Maybe inspection, calibration, internal audit, corrective action, right? Processes with inputs and outputs inside of departments. So I make this distinction because if you're going to audit by process, or if tomorrow after you hear my presentation, you're going to redesign your quality management system by processes, you need to know what they are, and you need to also know what they're not. So at the bottom of the screen, like I said, if you're trying to decide if something is or isn't a process, you ask yourself, what is the input and the output of this alleged process? And if there's no easy answer, it's likely not a process. Now, processes like manufacturing, right? I'm going to make stuff with inputs and outputs. A process can have many departments inside of it, right? If I am manufacturing, I might have a department called production, and my operators who make the parts maybe report into a production supervisor. I may have material handlers who deliver parts in and out of my work cell with fork trucks. Maybe they report into a boss in a material handling department. I have inspectors that may report into a quality assurance department. I have maintenance and setup, again, maybe reporting into a maintenance department, etc. And sometimes people get all bent out of shape because they're trying to think about departments, right? Oh, well, this guy reports to quality and this guy reports to production. From a process perspective, everybody does something. It doesn't matter who they report to. It doesn't matter who their boss is. Isn't that irrelevant? If you think of a flow chart, every step is being done by somebody. And it doesn't matter what department they're in. Process thinking. The other thing, I think it's in a slide further down, but I'll just mention it right now. Processes, like we just said, have inputs and outputs, and that's a way that we can tell what is and what isn't a process. Processes are also verbs, right? Laundering, cleaning, barbecuing, assembling, washing, driving, buying, building, developing, right? Those are verbs. That's another clue. Processes are verbs. We talked about HR. HR is a noun. Inside of HR, we have training, we have hiring, we have negotiating, insurance plans. So that's something else. Stay tuned. All right. Now, sometimes we get a little bit confused about inputs. We tend to think about a process sort of converting an input into an output, and that's sort of a classical definition. But there are certain processes that, in fact, the input is a little bit not that. I'll give you an example. We know that if I'm making a plastic part in a molding process, I'm transforming plastic resin right through a series of steps into some kind of part. I'm transforming plastic into a part. You might say I'm transforming a time card into a paycheck, right? Transformation. Think about blood donation. I have a blood donor clinic. And is donating blood at the Red Cross a process? Sure it is. There's a series of steps. The output is blood. But what's the input? Now, I could literally say that the input to the blood donation process is Dennis with 8 pints of blood, and the output is Dennis with 7 pints of blood and a little bag of blood. Ew. That's literally true, but that's a little bit clunky. Let's look at inputs another way. Look at inputs like a trigger. Could we say that the input to the blood donation example is I walk in, and as soon as I walk in, I trigger the process to start. All the nurses are just sitting around doing nothing until I walk in, and then the big wheels start turning. So think of an input as a trigger. I actually thought of this about 15 years ago while I was cutting my grass, because when you're me, your mind is consumed with these things. It's a curse. But anyway, how about a computer? You have a computer in front of you. We literally talk about computer inputs, right? An input to a computer is literally you press a key, right? I press a key and I'm changing the screen back and forth, computer input. A computer input is a signal that the computer receives from outside the system, okay? My input triggers something to happen. Let's think about inputs that way. Purchasing. Yes, I can transform my need for something into a purchased product, but isn't it more precise to say that a purchasing process is triggered by some need? My inventory level falls too low, right? I give the purchasing agent a requisition, right? So purchasing, buying something is triggered by a need. Same thing with calibration. If you think about it, calibration is usually triggered by a monthly gauge list or damage to a gauge, etc. And then the process of calibration begins, and out comes my fully calibrated gauge. So I wanted to throw that out there because it's another way to think about inputs. I won't spend a lot of time on this, but I just want to say, when you look at a flow chart or when you look at a turtle diagram, the best, in my view, the best way to know if they've done it wrong is to see how many inputs they've listed. I see this all the time. I see a flow chart or a turtle diagram like 20 inputs. No, there's not 20 inputs. There's usually one, maybe two. People love to confuse requirements with inputs, right? They put requirements in the input box, or resources. They put resources in the input box, and that's incorrect. If I'm going to barbecue a steak, right? Having my customers need to have it medium rare is not an input. That's a requirement. Propane is not an input, right? If I'm doing laundry and I have laundry soap and I have hot water, those are not inputs. Those are resources. There's a singular input, dirty clothes. So take a look. If you see several inputs, chances are they don't understand process, and they got it wrong. All right, where were we? Okay, verbs. I already said this. Now, I already said that processes themselves are verbs. So is every step inside a process. If you think about it, right? Here's an example from an ASQ course I teach. I'm going to make frozen French fries. Now, every step in there begins with a verb. I receive my potatoes and I clean them and I sort them and I remove the skins. I slice them, dice them, fry them, dye them, cook them, dry them, freeze them, bag them. Verbs. That's pretty cool. Processes are verbs, and every step inside the flow chart is a verb. So think about that as you're doing flow charts. So there's two ways to recognize a process. Processes use inputs to achieve an output, right? Use the definition of process as our acid test to help us determine what is and what is not a process. Then processes and each associated step, like I just said, are verbs. Okay, we're half done. And at this point, I want to invite any questions or comments. It's important that you're with me to this point and that everything's locked up solid. If there is a question or comment, we have a few minutes baked into this to take it. If not, I'll just move on.
You know, this is Ashok. I think you've done a great job in explaining the difference between inputs and outputs. A lot of people don't understand. Like you said, they'll have multiple inputs. I've seen it and I've done it myself and I'm guilty of it, but I think you make it very clear today. So I really appreciate it.
Thanks, Ashok. I appreciate that. Anyone else?
Dennis, I'm going to request that you turn off your camera. It keeps your bandwidth keeps slowing down the audio.
Okay, I will do that. And then the bonus is you don't have to look at me. Thanks for that feedback, Duke. I appreciate it. All right.
Will we have access to your slides?
I think so, right, Duke?
Yes.
Okay.
Great.
Thank you.
All right. Let's move on. And of course, then there's time at the end to talk about this stuff. Right. So we're going to settle a bet. Years ago, the standard just talked about, you know, we're going to have procedures for everything. And we know what procedures are. They're usually just a big, you know, multi-page, wordy procedure. And for a long, long time, there was some level of controversy whether or not a flow chart could be a procedure. Well, I'm happy to report that dispute has been settled. It's been settled for many years now, and flow charts are accepted by auditors, and I'll say more or less universally accepted as procedures, as they ought to be. If you read that definition on my screen, the definition of a procedure is a specified way to carry out an activity or process. So of course it can be a flow chart, absolutely. So again, giving a little bit more permission to use a flow chart. Business processes, right? So processes flow with a logical sequence. Think flow charts. They convert inputs into outputs. They cross several departments. I mentioned that, right? In a manufacturing process, I can have a production department, a quality department, et cetera. And then I also showed you that the output of each block in a flow chart becomes the input to the next. So here's another example. It's really like the one that I showed you already. The difference here is that in orange, we have what I just call the making stuff processes, right? We get quotes and we get contracts and we design stuff and we buy stuff and we make stuff. And, you know, so those are sort of, you know, direct processes that add value, et cetera. But let's remember that in a quality management system, we also have support processes. We have maintenance, we have hiring and training, corrective action, internal audit, et cetera, right? So we know that there are sort of the making stuff processes and there's the support processes. In our QMS, we have to consider all of them. In a typical business, there's about 20 processes, you know, give or take. And now what I tell my clients is you decide what those 20 key business processes are. You make a series of 20 flow charts, you stick them together, there's a quality manual, and your quality manual now is literally a set of flow charts. That is using the process approach as the basis for your QMS, really the theme of this presentation. A system is really just that network of processes and their complexity and the processes and the web and the way they all fit. That's the system. Let's talk quickly about aspects of a process. This comes from some work I did about 20 years ago. when I was talking about risk-based auditing. But if you think about it, processes have aspects of the process that enable your process to be successful, right? And you can borrow the fishbone diagram. So every process is going to have the man or the people, and they're going to have materials and machines and methods and measurement, and we decide what those are, right? We decide what materials we use, what machines we use, we design the methods, we decide on the people and the skills that they have to have, etc. So the 5 M's are aspects of the process that enable it to be successful. We design these in, and we just now plug them in next to the steps in the flow chart where they belong. So I'm going to show you my teaching example. This is the one I always use. We're going to go to work. We get out of bed, we take a shower, we get dressed, and of course I'm Canadian, so we've got to drive to Tim Hortons on the way to work and get coffee, and then we drive to work and we walk to our desk. So then what you can do is you can just think about what are the enablers for this process? And you can think about the 5 M's and you can say, all right, I'm driving to work. Who are the people involved? It's you, it's me, maybe it's the person, you know, selling me coffee. I've got materials in the process. It's the toiletries I use when I'm taking a shower. It's the clothing I wear. It's the coffee I drink. Maybe the machine could be the shower. It could be the car. There's methods. Right? Each of us every morning going to work, we have a routine, a daily routine for getting ready. And we have the route that we take when we drive to work. And then there's measurement. At various points in the process, we can measure the process. When your alarm clock rings at 6 o'clock in the morning, the first thing you do is you look at your clock and you make sure you didn't sleep in. That's measurement. Maybe you're driving down I-75, I think comes through near where you guys live. You're coming down the I-75, you're checking your speedometer. Am I on track? Am I going to get to work? And then as soon as you get to work, you look at the clock to make sure you're not late. So we have these M's, we have these aspects of process that we design, and these are the M's, these are the aspects that enable our process to be successful. So here's the model that I'm going to show you. It's a flow chart, but here's how I do it. And here's how maybe I encourage you to do it. So we have our process, and then we just align our enablers, these 5 M's, we just align them next to the step in the process where they belong. So we get out of bed. The enablers that enable that step are my alarm clock, maybe a desk lamp, because when you wake up at 6 a.m., it's dark. You got to turn on a lamp so you don't get hurt. You're going to take a shower. Well, then the enablers to make my shower successful are the shower and the soap and water and the shampoo, etc. If I'm going to get dressed, I need my clothes. If I'm going to drive to the coffee shop, I have the car, the route that I take to work, my speedometer. These are the enablers. I get my coffee. I have the person that sells me the coffee, and I have the coffee itself, etc. And if you look at this list, you see that I've just combined the M's, right? So if you look at step 2, the shower step, the shower is a machine, and then the soap and water, etc., are materials. If you look at step 4, as I drive to the coffee shop, I have a car, which is a machine. I have the route, which is a method, and I have the speedometer, which is a measurement. So we combine the enablers, and we just list all of the enablers next to the step where they belong. And not every step has every M, right? There's not usually all 5, but there can be 2 or 3, as I just demonstrated. So in the enablers that we have on the right, we can include the enablers. We can include requirements and process controls and procedural references. So think about this. Here's a smaller example. In manufacturing, I'm going to set up a machine, and maybe I'm going to run off a first part and do a first off inspection. So here in black and red, I've got some enablers. right? So to set up the tooling, I have enablers. Setup cards are used. Each tool has its own setup card. Setup pegs do work. Calibrated torque wrenches are used. Maybe I retain my setup records for 7 years. Then my second step is to run the first off part and inspect it. So maybe my operator runs the part. My QC inspectors inspect the part. That's me now describing who does what, because we need to do that. Our inspectors are trained to measure the parts, which suggests I now have an audit trail for training. Here's a procedure. It's QC FO1. I have an inspection form F999. Maybe I have a rule that my machine doesn't run until QC gives the approval. And in this example, the red text are my controls, my procedures, things that might be auditable. And the text that I have there in black is more just commentary, more just explanatory. Now, if I have a flow chart with 6 or 8 steps, keep it high level, with all of these enablers listed at each step, they're the M's, they're procedural references, their requirements, right? All of these go in the column together. Now I want you to picture that, right? I've got this whole process, we're going to work. I've got all of these sort of enablers listed. Now I've got a flow chart on one page. Doesn't it look like an audit checklist? Wow. The flow chart is a procedure and it's an audit checklist. Like, how cool is that? Simple, easy, intuitive. I teach a lot of internal auditors. And a lot of internal auditors maybe come from a shop floor level. And they're not college grads. They need simple. And it's hard for me to teach them how to audit a complicated process, a complicated QMS. That's hard enough for me, and I do this for a living. So for heaven's sakes, do yourselves and your internal auditors a favor, design your QMS to be simple and intuitive to use and simple and intuitive to audit. Design your QMS to be auditable. And this is one way to do that. So this approach that I just showed you with the flow chart and with the enablers and the enablers is really the way I do it. I'm going to show you the 4-box model, and I guess its cousin, the turtle diagram. I'm showing you these not because I like them very much, but because they're very common. And you've probably seen a 4-box model. You've probably seen a turtle diagram. I'm just going to show you a little bit how what I just did can fit into these other models if these are the models you're currently using. So this 4-box model, you recognize it's a process. It has inputs, it outputs, it has resources, and it has controls. Now, if I'm driving to work, this might be what it looks like, right? The input is an employee in bed, right? The alarm clock is the trigger, and then through a series of steps, the output becomes the employees at their desk ready to work on time. On time is the objective of the process, or maybe it's the measurable of the process. At the bottom box, I have resources. I have hot water, and I have toiletries, and I have clothing, and I have gasoline, and I have coffee. None of those are inputs. All of those are resources. They're used in the process, but they're not inputs. Above, I have maybe controls or methods, right? Controls. Above, I have the alarm clock, I have the routine I use to get ready, I have the route that I take to drive to work, I have speed limits and traffic signs and automobile controls, etc., etc. Now, I think you'll recognize, and if you're not going to recognize it, I'm going to just tell you, you see why the 4-box model or the turtle diagram is less desirable than a flow chart. I have an alarm clock. I don't know where that belongs in the process. I have a route that I take to work. I have automobile controls and speed limits. They're in there somewhere in the process, but because I don't have a flow chart, I don't know where they belong. Look at those resources. I have hot water, toiletries, clothing, gasoline, and coffee. Yes, those are all resources used in my whole process, but I don't know where, right? Is gasoline used in the waking up step or in the getting ready for work step? No, it's only used in the driving to work step. Hot water, where's that used? Maybe that's used in the making coffee step. Well, no, it's used in the shower step. So if you use a 4-box model or you use a turtle diagram, turn it into a flow chart and align all of these controls and resources in the process where they belong. Please. I've been at this a long time. It's just too easy. This way is not intuitive. It's interpretive, and often we interpret it wrong. So, but again, I give it fair treatment. A lot of people use this model. If you want to use this model, fine. This is how you would do it to make the architecture of your quality management system process-based. Before I leave the slide, I'll just say a lot of people who use turtle diagrams now, 10 years later, 15 years later, 20 years later, have recognized that it's not that great and they want to do something else. And that something else is convert your turtle diagrams to flowcharts. And I'm literally just showing you how to do that. What else? And then you just create a flowchart, right? The process model starts with the flow chart. There it is in green. We have the process steps. It's a flow chart. We have enablers in yellow. We talked about that. And then we have risks. Now this comes from another presentation. We're not talking about risks, but think about it. How easy would it be to put risks, right? Because we all have to do risk-based thinking. How easy would it be to put risks next to the enablers in the flow chart? Right? Pretty easy. I have a flow chart with a series of steps. Every step has some enablers that I put into place. Every step has some level of risk. I consider them together. And then responsibilities. Who does what? You just drop it in on the left next to each step. Nothing could be easier. And then maybe at the bottom, some measures of the process, right? Our quality management system tells us we should have measures of the effectiveness of our processes there. You drop them in at the bottom, done. We'll talk a little bit about the process approach. If you read the standard in clause 0.3.1, right, the ISO clause, the standards writers want us to understand and use a process approach. And there's the language from the standard. I don't have to read it to you, but we know that that's true. A process approach makes your quality management system more natural for you, more relevant, easier to use, easier to audit, and more aligned with your reality. Oh, here's another way you can look at it, right? So this is the same flow chart I showed you on the previous screen, but I'm slicing and dicing it just a little bit differently. Some folks want their flow charts to include the plan, do, check, act. Fine. Sometimes I do it that way, sometimes I don't. But if you want, right, in a manufacturing example, you could include maybe your first couple or 3 steps could be planning steps. So maybe the first step in my manufacturing process is, maybe my first 2 steps is, get customer releases and then create a schedule. And then, you go out and you give the schedule to the plant, you set up the machine. So you could totally start your process with the plan steps. And then of course it's the do steps. And then maybe some check and act, Could be metrics. Could be some reaction. Could be some reference to a rework loop. So you can do it this way too. Plan, do, check, act. Some of the folks that I've taught this to have done it this way. That's why it's in my presentation. It's a good approach. All right, I think this is the last slide. I know you thought it would never come. So by way of recap, do and don't. Do, use a flow chart that portrays your real process, not the language of ISO 9001. Let's face it, nobody but us cares about the language of ISO 9001. They don't care about the numbers of 9001. Nobody knows what the heck product realization is. Make it real. And your internal auditors and your process owners, they want to use your lingo, not the language of the standard. So use the real process. Don't use ISO language. Keep it high level. I want you to trust me on that. This model works best when it's high level. 6 boxes, no more than 8, using verbs, as we talked about. Add lots of text for your enablers, your controls, your requirements. Your flowcharts become procedures and they become audit checklists. Wow. A flowchart is a procedure and a flowchart is an audit checklist. A turtle diagram is neither one. And finally, do use flowcharts as the very architecture of a QMS. That's my message tonight. Don't use abstract models like the 4-box or the turtle. It gets you in trouble. You got to spend, you know what, I've taught these things. I've taught lead auditor courses for registrars and I have to use their material and I spend half the day teaching somebody a turtle. Like, really? If you went to high school, you know how to use a flow chart. It's easier, it's more intuitive. So don't use an abstract model like a turtle or a 4-box. And for heaven's sakes, please don't follow the clauses of the standard. Yikes. All right. What did we do? What did we learn? I took you through the definition of a process. We talked about the aspects of a process. We use the M's, the man, method, material, etc. We talked about inputs and outputs, literally using the definition of a process as a way to determine what is and what isn't a process. We talked about enablers and controls. We talked about resources and how resources are not inputs. We talked very briefly about performance metrics. I hope I convinced you of the benefits tonight of the process approach. We also talked a little bit about processes versus departments, and they're not the same thing. And then very briefly, assigning responsibility for each step. You literally just say beside each step in the flow chart, who does what. It's just too easy. All right. Thank you, everyone, for participating in this presentation. And I'm going to turn myself back on and